Hello, ladies and gentlemen. Welcome to another edition of Let's Code. So happy to have you. Today we're going to be coding up a queue, and we're going to be using Java as our language of choice. So a queue, if you're not familiar, is one of the basic data structures in computer science. It represents, imagine a line at the movie theater and everyone's waiting to get tickets. So as people start to line up, the first person that lined up is the first one to leave. So it follows the first in, first out paradigm. The first entry into the queue is always the first entry to leave the queue. So this is opposite of its cousin, the stack, which do see the Let's Code a Stack video I posted. The stack is the opposite of that. So once again, we have a stack of plates. The last one in is the first one out with a stack. So stacks are used typically for stack traces and other things in computer science. Queues are a lot of times used with priorities. For instance, if you have a bunch of processes who are trying to get CPU, they might have a priority queue set up for that, and you'll be able to reward those processes with CPU power based on their entry in that particular queue. So let's dive right into it. We're going to be using a simple circular array-based implementation today. The circular array is going to allow us to just keep moving and reusing elements inside the array so that when we get to the end of it, we don't end up with an issue. So in order to do that, we're going to need to keep track of two things. We're going to need to keep track of a value representing the array index of the first item. We'll also need to keep an integer reference of the index of the next available item in the array. And we also want to have a capacity defined. And we're going to set a default capacity of 10. So what we're saying here is, hey, I'm going to instantiate an array with a default capacity of 10, so you can only have 10 items in the array at any time. So the downside of this easy implementation is that size constraint. We have to know the size up front, and if we reach the capacity of the size of the array, we run into issues. So it does have some drawbacks, but it's still important to know and and it really helps to conceptualize the idea of what a queue is when you use a data structure that's pretty bare bones. So we'll be backing this guy with an array of type T, and we're going to name the array Q for Q. So let's go ahead and add our constructor. And in the constructor, I want to be able to pass in the capacity. So if I'm creating a new instance of this queue, I want to be able to say, okay, give me 20 objects initially, or give me 30 objects initially. And then we're going to go ahead and instantiate queue equals, this is our syntax to basically allow us to create a new object array of type T. And we're going to set that initial size of the array to capacity. I also like to go ahead and just add a simple empty constructor that will accept the default capacity. So as you can see, we did make this a generic queue, so we went ahead and specified T for the type. So when it actually gets instantiated from code, you can specify what that type is. Is it an integer? Is it a string? Are you storing nodes? Are you storing a custom class? You have a lot of different options there. So now we're going to implement a couple of methods here for our simple array-based implementation. One thing to keep in mind, and maybe you're not familiar with the modulo operator, which in Java is this guy here. And basically it's the remainder. So if I say 4 modulo 2, that's going to give me a value of 2. Because 4 divided by 2, it goes in twice. I'm sorry, that will give me a remainder of 0. There's no remainder when you divide 2 by 4. If I were to do 5 modulo 2, I would get a remainder of 1. So the modulo operator here is going to help us when we get to the end of our array to circle back to some of the initial indexes to reuse that. So just keep that in mind. If that's not clear, please just look up modulo operator, get familiar with that, play around with it, and get some experience with that guy. So we're going to define our size method here. And what that's going to return is capacity minus f plus r modulo capacity. Okay, so that might look a little weird, but basically we need to know the size of the array, and since it's a circular array, that means we can't just return q.length, right? Or we can't just return the difference between f and r, because it could have potentially wrapped around, and that might be partially confusing. So we have to do the mod capacity, which will give us the remainder if r has actually looped back around to the beginning. Okay, now we're going to add our isEmpty method. And basically what we're going to be able to do here is return if f equals r. That means the index of the first object is equal to the index of the next available object, which means there's currently nothing in the queue. Okay, now we're going to implement our front method, which is going to return type t. This is going to give us the item that is currently in the front of the queue. Okay, so what we're going to do here is first we're going to check if size. We're actually going to do another method. Let's do isEmpty here. If it's empty, I'm going to return null. Now you could return anything you want here or throw in an exception. You can get creative, but like I said, I want this to be bare bones and not that complicated. So if it's empty, we're going to return null, else we're going to return q at f. So we're going to return the array at index f, which is the front. And this is just going to return the object. We're not actually going to remove it from the array. So that's fine. Next, we're going to implement our dequeue method. This is the method that is actually going to pop it off the queue. So first we want to check if is empty. I'm going to just return null again. Else, what I'm going to do is set a temp variable to q at f. And then I'm going to set f equal to f plus 1 mod capacity. And once again, the reason that I'm doing mod capacity is, let's imagine we're at the very last index in the array, and now we've done f plus 1. So let's say we have a capacity of 100, right? And now I've just said 100 plus 1, so now I'm at 101. But my max capacity is 100. If I try to access index 101, I'm going to get an index out of bounds exception. So 101 modulo 100 is a remainder of 1. So now you can see how that sort of helps us loop back around to where we need to be. And that's where that modulo operator comes into play. And that's the only confusing part about this particular implementation, is how that wraparound works. But once you get the hang of that, it's pretty self-explanatory. Okay, so that's our dequeue. Next up, we need to know how to enqueue an object. And we're just going to leave this as a void method. Okay. If size equals capacity minus 1, there's a reason we want to do capacity minus 1. If we're only checking if the size is equal to capacity, we might run into an edge case where f equals r again, and that would cause our algorithms to break. So what we do here is we want to make sure that we always have capacity minus 1 objects before we're allowed to actually insert anything else. So here I'm just going to throw a new runtime exception. Q is at capacity. Else, what I'm going to do is set Q at R equal to. Now, if we're enqueuing something, we obviously need to know what that is, so we need to pass that in as a parameter. Q at R equals object. And now R is going to equal R plus 1 modulo capacity, once again to account for that wraparound. So now we've got our front method, our dequeue method, and our enqueue method. Front just returns the object that's on the front. It doesn't modify the queue structure at all. Dequeue will actually modify the queue. It will return the object that's on the front and move our front object to the next element in the array. And then we have our enqueue, which will add an element to the queue. So it's going to set the Q of R equal to the object, and it's going to increase our R so that the next time we do an enqueue, it'll be at the next element in the array. And I'm going to add a print method here. If it's empty, we're going to print empty. Else, for integer I equal F, which is the front. We always want to start at the front of the array. For integer I equals F, while I is less than R modulo capacity, I plus plus. Okay. And what we're going to do here is we're just going to print that out. We're going to print out each item here, Q of I, and then a space. And anytime we do an enqueue, I want to call that print method. And then print out a new line. So basically that'll show us live as we insert items into the queue. It'll show us those steps. So now let's create our main method. PSVM is a shortcut key in IntelliJ to go ahead and write this template for us, the main method. And what I want to do is I want to create a new queue of type integer. And I'm going to name it integer queue. And let's just add some things to the queue. So integer queue dot enqueue new integer 1. I'm going to go ahead and add 5 items here. And then let's run it. And we should be able to see those be added. Our print method should catch those. And we should see 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. So as you can see here that our queue is working as expected. So let's go ahead and let's pop something off. And after we pop something, let's go ahead and add that print method as well, just so we can see what's happening. Okay. And we'll add this inside of here so that it's reachable. All right, let's go ahead and dequeue. So after we dequeue, we would expect 1 to disappear and 2, 3, 4, and 5 be the only elements inside of our queue. So let's run this and see what we get. 2, 3, 4, 5. Excellent. So let's go and add another value of 100. And we'll add another value of 101. And let's see what we get. 2, 3, 4, 5, 100, 101. That's what I would expect to see. Perfect. Now let's do 3 dequeues in a row. And at this point, I'm just playing around. Like anytime you're writing code and you're trying to learn new things, write your code and then just play around with your methods, see what happens. You could even put some debug statements in and walk through the code if you're not understanding it. This is where the real learning happens, is after it's written, when you just start, trying to make sure everything works. And you can write test cases as well. This is kind of more of an ad hoc approach to testing, but write some test cases. That way you have them in the future. So I did 3 DQs after the add. So 3, 4, and 5 should disappear. 2, 3, and 4, I'm sorry. And they did. And everything looks good. So that is the simple and dirty implementation here of the queue using a circular array. Remember, the main thing is this capacity and the modulo operator. That's what really allows us to have that circular array and keep reusing those values. Another thing to note is we are only allowing capacity -1 objects inside of here. So that is a drawback to the design. If you know exactly how many items you're going to have in a queue, this would work. Otherwise, I think we want these days a more flexible solution where it can grow as needed. But this is very efficient. Every operation runs in constant time. It's a very fast data structure. And yeah, that should give you a sort of an idea of what's going on. As always, do visit mindfulbit.com for blog posts about soft skills and how to be successful as a software developer in today's fast-moving environment. And I look forward to seeing you on the next video. Take care.